Hello, welcome to section 3.3. This is about the atom. In order to really talk about atoms, first we have to go through something called Dalton's atomic theory, and this theory's been around for hundreds of years. Basically what Dalton stated was that atoms are tiny particles of matter. Atoms of an element are similar to each other and they're different from all the other elements. The atoms of two or more different elements can combine to form compounds, and atoms are arranged to form new combinations in something called a chemical reaction. So atoms contain subatomic particles. They're made up of these. They're made up of protons that have a positive charge, so protons positive. They have electrons, which have a negative charge. They have neutrons, which are neutral, that is, they have no charge. And something to remember about this is that if the charges are the same, they tend to repel each other. If they are different, they tend to attract. And if you think about a magnet, if you put two magnets together and they're the positive and negative poles, what will happen is they will be drawn to each other, okay, and they'll kind of go together. If you have magnets that you have the opposite of that, you put a positive towards a positive, what they're going to do is they're going to repel each other and go away from each other, okay. And so it's the same thing with protons and electrons. If you have two protons, they will repel each other. If you have two electrons, they will repel each other. But if you have a proton and an electron, they will be attracted to each other. Opposites do attract. And so there was an experiment by a gentleman named Rutherford. It's called the gold foil experiment. And this is where we first found out about these positively charged particles, and it told us a lot about the nucleus. Okay, he took some positively charged positrons and aimed them at gold. He had some gold foil there. That's why they call it the gold foil experiment. Most of these positively charged particles went straight through the atoms that he was shooting them at, but some were deflected, but only occasionally. Okay, so what that told him was that there must be a small, dense, positively charged nucleus in an atom that would deflect those positively charges. So it was mostly space, okay, that deflected straight through, but every once in a while it would be reflected back because it hit something that was positive. So he decided that these positive charges were in the nucleus, in a nuclear region, and the rest of it was mostly space. And so indeed we have come to believe that an atom consists of a nucleus that contains protons and neutrons, and then the electrons are in a large empty space that are around the nucleus. An atom has mass, okay, and so we use something called an atomic mass unit to describe this. By definition, one atomic mass unit, or an AMU, is a mass equal to 1/12 of the mass of a carbon-12 atom. So a proton has a mass of about 1.007 AMU. A neutron has a mass of about 1.008 AMU. An electron, though, has a very, very tiny mass, and so we pretty much just don't even bother thinking about it. It's like if you were going to step on the scales and weigh yourself, and the difference in your weight would be having maybe a few grains of salt or something. You know, how much difference would that make? Not much. So To summarize these subatomic particles of the atom, you have a proton that we write either P or P+. It's a positive charge, mass of about 1, found in the nucleus. The neutron is an N or an N0, has a 0 charge because it's neutral. It has about a 1 mass, and it's found in the nucleus. The electron, E-, is a -1 charge, very tiny mass, and it's found outside the nucleus. So most of the mass of an atom is found where? In the nucleus. So for your learning check, which of the subatomic particles fits each of the descriptions below? Found outside the nucleus. Electrons, maybe? Has a positive charge. Positive equals proton. And has a mass but no charge. If it's got no charge, then it's neutral. So that's probably what? A neutron. Very good. So that's the end of section 3.3, the atom. If you're ready, go on to section 3.4. If not, take a break, make a sandwich.